As you must know, load handling, moving, and lifting takes careful planning. Although it may seem like a cakewalk to accomplish these goals with the help of implements like levers, jacks, and rollers, the fact is, serious injury can occur if we use the equipment improperly. Knowledge about the correct and efficient use of these tools is important to handle, move, and lift a load safely and without damaging it. So let's go through this module to acquire key skills in using levers, jacks, and rollers correctly and efficiently. To begin with, let's list the objectives of this module, which will give you a brief outline as to what this module covers. After completing this module, you will be able to explain the concept of mechanical advantage and how a long lever reduces the amount of effort required to lift a load. You will also be able to compute the share of load weight at jacks and pounds per square inch, or PSI, at the load's contact surface. Finally, you will be able to identify the best position for roller placement under a load. Mechanical advantage is the factor by which a mechanism multiplies the force applied to it. Thus, achieving a better mechanical advantage means reducing the amount of effort required to lift a load. While lifting a load with the help of a lifting bar, Johnson bar, crowbar, or any other implement, it is important to achieve optimum mechanical advantage. This will ensure that you apply less effort to lift a heavier load. Let's go through an example to learn how to achieve a better mechanical advantage. In this diagram, the tipping axis is at O. The distances A and B on either side of O are equal. In this case, if you will apply 100 pounds down at side P, you will be able to lift 100 pounds at the opposite side Q. Now, if you move the tipping axis towards the right so that distance A is twice the distance of B, by applying the same 100 pounds on side A, you will be able to lift 200 pounds on side B. As you can see, the ratio between A and B is 2:1. Therefore, 100 pounds multiplied by 2 will be equal to 200 pounds multiplied by 1. The equal sign in the equation identifies an equilibrium that you have achieved with the ratio 2:1. The same can be achieved with a 3:1, 4:1, or 5:1 ratio, and so on. In this case, by shifting the tipping axis towards right, you are able to lift double the load you would have lifted otherwise. Thus, mechanical advantage is equal to 2. Let's consider another example to learn how mechanical advantage is achieved. You will learn that a longer lever requires less effort to lift a load, which ensures a better mechanical advantage.